virtual machine, backup, restore, and disaster recovery. In this nugget, we're going to talk about the all-important task of backup and restore, and then we're going to take what we know about backup and restore, and we're going to apply it to the concepts of disaster recovery. And really, rather than talk about what we're going to talk about in this nugget, you'll see here in our introductory slide, we're going to talk about what virtualization adds to your environment, and what about virtualization that can it do to improve your backup and restore posture. You'll see here we talk about virtualization and adds backup options, and then that's a good thing because you have different options in how you can back things up. You can back up the individual files, the traditional approach, or you can back up the VMDK file and back up the entire virtual machine as one. You can back up, if you have RDMs, if you have raw device mappings, you can back up those raw device mappings. But adding in all those backup options also adds complexity to your backup posture. The type of backups you're going to have to choose are going to get a little bit more complex depending on what you need to do. And so something that for so long that we have really kind of forgot about, and that's the idea of what's the best practices approach to doing backup. We've kind of just let our backup software just do its thing for so many years. Now, because we're adding virtualization into the mix, we have more choices, and we have to sort of rethink what we're interested in and what we actually want to do with backing up. Now, we also want to talk a little bit about disaster recovery. Now, backup and restore is one thing, but also being able to port those backup and restore items off to a remote site for disaster recovery is another option as well. And what's neat about virtualization, especially when we talk about image level backups, virtualization adds some cost-effective disaster recovery options. And we'll talk about some of the, not only the less expensive ones, but all the way up to the more expensive ones for depending on what you're looking to do. Before we can start with any kind of conversation about backup and restore, though, we need to talk about some terminology. And I want to start by saying, first of all, for this particular nugget, we're not going to go through any demonstrations. We're going to be doing a lot of whiteboarding and talking from a very general level about the items associated with backup and restore. But we're not actually going to see any backup and restore because there are so many different tools out there that it wouldn't be worthwhile to show you one tool because you may have a different tool entirely. Now, there are a couple of different types of backups when we are involved with virtual machines and virtualization. We have what's called the file level backup, and then we also have an image level backup. And the file level backup is really what you think of when you're used to thinking of your traditional backups. A file level backup involves a client that sits on a machine somewhere, and that client captures the files and sends them off either over the LAN or over a fiber connection off to disk. And then on that disk is incorporated the thousands or 10,000s or millions of files that encompass that machine. An image level backup is different because when we move to virtualization, all of those files are comprised and moved into this little database file called a VMDK file. And that VMDK file can be backed up as well as a single file and restored as a single file to another location. Now, obviously, you can see there's some pros and cons to the two different types of backups. If I'm doing a file level backup, the backing up is very, very easy because I just go ping, 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 and just installing clients all over the place and copying my files and sending it over the network. And the restoration is really nice too, because if I need to restore a single file, that's very easy. I just go, I click on the file that I need to restore, and I click restore, and then bang, it's done. But with file level backups, if I need to use those to do a bare metal restore of a failed system, that's where file level backups really cause problems. If you've ever tried to restore a backup of a machine over the top of an existing machine to try to do a bare metal restore, you've seen these problems where locking and contention issues prevent certain files from being backed up appropriately, and then sometimes it just doesn't restore the machine the way it's supposed to. Where we can get over that is with this concept of image level backup, which is where we back up the VMDK file. Now, when we back up the VMDK file, it's a single file that we're backing up, and we're backing it up at a point in time so that for us to restore it, we only need to restore one file. We don't need to restore 10,000 files. And we know if that restore goes well, then we should have a functioning operating system again. For us to be able to do an image level backup, however, there is this concept of quiescing. And quiescing is a big fancy word that essentially means that we're going to quiet the system for just a moment so that we can take a mini snapshot of that system and complete the backup off of a system that is considered crash consistent. We'll talk about crash consistency here in a second. But there are lots of different levels of quiescing. If you're a Microsoft person and you're used to Windows and the Windows VSS service for volume snapshot service, where you can go through and snapshot all the items on your in your machine or in your file server, then you're familiar with the idea of quiescing. What we're doing is we're essentially taking a little mini snapshot of the elements inside of our system so that the VMDK file is quiet long enough so that we can create a backup of it and it be crash consistent. Now, anytime that we do quiescing, we have to do that in order to get to what we call OS crash consistency. And that's the idea that if I try to back up the file without quiescing it for a period of time, when I restore it, some sort of operation may have been going on while that file was being backed up, and then we won't actually get the correct file. It's too dynamic. So we have to quiet it and snapshot it for us to be able to have that moment in time so we get crash consistency. If we don't do the quiescing of the file, the VMDK file, before we do it, then the dynamic nature of the VMDK file means that we're going to end up with just garbage, and garbage in equals garbage out. Now, quiescing is also important as well when we talk about application crash consistency as well, because quiescing our VMDK file means that our operating system is functioning just fine. But inside of that operating system, we may have things like transactional databases or other types of databases that don't behave well when they're not quiesced as well. Now let's deconstruct this even a little further. If I go and install Microsoft Exchange onto a Windows box, and it's functioning happily and it's serving mail and doing its thing, and then somebody goes and pulls the plug from that Exchange server and poof, it just drops off. When we bring back that Exchange server, the database was not shut down in a good state, in a known good state. And so you have to do some work actually to get the database back into the correct state so it's functioning and happy again. And that's really, it went down. It wasn't crash consistent when it came back up. And if we try to do a backup of our VMDK files without having some sort of agent that sits inside of the virtual machine itself and completes that quiescing of the application as well, then we may end up with OS crash consistent, but not application crash consistent. And so the differences between this concept of OS crash consistency and application crash consistency is really going to determine what your backup strategies are going to be for the systems on your network. Really, the rule of thumb is if you've got a server that does sort of static work, if it's a file server, if it's a web server, those sorts of things, if it does not have a transactional database inside the server, then you can usually do this image level backup without some sort of agent needing to be in the system. If you do have a transactional database on your server, maybe it's an Exchange server, or a SQL server, or a domain controller, then you have to either shut down those services before you do the backup, or you have to have some sort of agent that instructs that inside of the virtual machine, instructs that database to quiesce itself as the OS is quiesced as well. Now, that being said, at the writing of this nugget, no agents like that exist. Now, they may be coming. They're on the plan for various vendors, third-party vendors, but right now we don't have the ability to do those agents. So if you're going to do image-level backups on transactional databases, be aware that you may not arrive back with application crash consistency if you attempt to restore the entire virtual machine. We do have a couple of options that we have whenever we need to think about backing up our virtual environment, and that's really, there's really two halves to the whole. The first is backing up the service console, and the second is backing up the virtual machines themselves. Now, the virtual machines themselves arguably are the more important parts, right? The service console is it's the Linux, it's the Red Hat that makes up ESX, it's the bits and the bytes that actually make ESX run. The data, your business data, is on your virtual machines, and so they're the really, really critical ones. But you do have to think about what you're interested in backing up. Now, this is just Greg's opinion here, but you remember back when we did the installation of ESX and how unbelievably easy it was to do an ESX installation. What did it take? Like 20 minutes to throw the disk in, pop it in, let it complete its thing, maybe even less than 20 minutes, maybe 15 minutes. So backing up the service console, if you don't have a lot of customizations where you've delved deep into the Linux and made customizations and synchronized time sources and synchronized, Samba shares and those sorts of things, if you don't have a lot of customization, you may not need to worry really about backing up the service console. If your system dies, if your ESX server dies, then DRS and HA is going to reboot all of the virtual machines on other hosts. So you don't really have any data that's sitting on that service console. It's all been moved off and it's already functioning just fine. So in a lot of cases, the disaster recovery or the restoration of the service console is easier, not by trying to restore from a backup, but by actually just throwing the CD back on the drive, rebuilding the server, and then putting the virtual machines back on it. So really what we're going to focus on for the rest of this nugget is the concept of backing up the virtual machines themselves, because again, they're where the data is. And we're going to talk about 4 options for that. And in fact, we're really going to talk about 6. But we're going to talk about the 4 options you can do for backing up your virtual machines. And it's important to talk about these 4 options because, as we said before, as we add in virtualization into our environment, we add in also some complexity to our backup options that are available to us. So I'm going to go ahead and minimize this, and I'm going to bring up the next one. This is option one, and we're going to go through these four options in turn. I'm going to draw a little picture of each of these options so you can take a look at as you're thinking about your environment, because we're most of the way through this series. We're getting to the point now where you're pretty much in operations at this point. You're up and ready to go. So as you're thinking about designing your environment, what sorts of options for backup do you want to consider? Now, the first option here is backup server in the virtual machine and the backup client in the virtual machine. And if we go back to our picture that we keep seeing all the time, and you'll see me draw this a few times. If we go back to this picture, the idea here is that inside of my VSX box, I have a virtual machine here. That's my net backup server or my backup exec server, or essentially it's the server that handles the backup responsibilities. So this is the backup server. We also have individual clients in our workstations too. And then here we may have these individual clients. And on these clients, maybe these are my Windows 2003 systems or my Windows 2008 systems. And on each one of these is my backup exec agent. So maybe I have some sort of agent that sits here inside of each one of these virtual machines right here. This is option one. Now, when we get to the end of the first four options, I'm going to show you what the pros and cons are for each of the options. But just be aware that for option one, we're going to have this backup server that's sitting in a virtual machine. So we have one virtual machine that handles the servicing of backups. And then also this backup clients that are in the virtual machines as well. And so we're doing sort of our traditional backups, but we've just virtualized it all. And that's option one. Now, option two I want to talk about is changing it around a bit and making the backup server a physical machine while the backup client's in a virtual machine. So here's my thing again, and here's my two ESX servers, and here we go. We got them connected into the data store. And I've still got my clients here, and they still have the agent installed on them, right? Here's the agent, and it's all installed on these. But we actually, outside of the virtual infrastructure, we have this backup server here that is outside but connected via the network. And so there's a network the connectivity between this backup server and the ESX server, and all of my backup traffic is going over the network. Now you can see here that there are some differences associated with doing this. Obviously, putting the backup server in the virtual machine has some pretty high load on that ESX server, because backing up, because it's so data centric, so data intensive, can be a pretty high load. So by moving it off and keeping it physical, at least the backup server functions are eliminated, and I'm not impacting my virtual infrastructure. But the agents too still have something to do, and so they're going to have some issues associated with the backup process as well. Now let's take it a step back from this concept of installing these agents out onto our, these net backup or these backup exec agents into all of our little virtual machines. And instead, for option three, we want to say, what if instead we want to make the backup server in a virtual machine, but instead of actually using a client on each one of our virtual machines, we want to put that agent instead in the service console. So let's take a look at that. Let's go ahead and then draw this again. And it's funny, these keep getting worse every time I draw them. So here's our two ESX servers here, and our backup server sitting here. There's our backup server right there. But instead of having an agent installed in each one of these virtual machines, instead I put a little widget here, which is the backup agent on the ESX box. Now, obviously, I have to have some sort of application that runs on Red Hat, and it also has to be able to support backing up of VMDK files. It has to understand VMDK files and know how to quiesce those VMDK files. But I can potentially have this backup server that's sitting inside this ESX box here, and it's communicating with this agent. This agent then, when it's time to do backups, says, okay, you go quiesce. You quiesce, okay, I'm going to back you up. Now I've got VMDK file 1. There's VMDK file number 1. Okay, well, now it's your time to quiesce. You quiesce, okay, I'm going to take VMDK file number 2. And then you go do it, and then we get 3, and we get number 4 here. So as you can see, by doing this, in option 1 and option 2, I'm going to have 10,000 files per system. And in option 3, I'm only going to have 4 files. I'm going to have vmdk.1 back, or whatever extension it ends up being, .back, and then vmdk.2 .back, and then 3 and then 4. So really, my manageability of my backups is much improved because I only have 4 files to deal with instead of 40,000 files to deal with, and that's really, really cool. So there are some pros and cons to this. So sit on this for just a second, and we'll get back to what the pros and cons are to this option as well. The fourth option, obviously, is that's option 3. Option 4 is the concept of the backup server being physical and the backup client being in the service console. So really, what we're doing here is we're taking the same architecture that we took before, with our little client being here, this little widget that we've got. Here's our agent, and then here's our virtual machines. And then instead, we just put the backup server out here. Here's our backup server, and the backup server talks over some sort of network to the ESX box, and then handles the quiescing that way. This is a good idea, again, because those backup server services are very, very intensive, resource intensive. And when we talked about the idea of which machines are candidates for virtualization and which ones aren't, if there's a high resource use on the part of our of a physical machine, we may not want to P2V it. So option 4 is a good idea if this backup server has a lot of resource use and we don't want it to be inside of our ESX environment. So those are our kind of the 4 first options that we really want to talk about. Now what I want to do is that now that we've sort of outlined what these options are, let's go ahead and put up a graphic to, I've got an Excel file here that's going to show some of the pros and cons of each of these 4 options. Let me go ahead and bring up this Excel file here. And to see, these are the four methods that we talked about, the 4 options we talked about: backup server and client VM, physical and VM, VM and service console, physical and service console. And we have some of the feature sets associated with these. And I'll admit, I pulled these right out of the VMware documentation. This is not my information. This is VMware's information. But you can see here that if we have our backup client inside of the virtual machine, it is very easy to do a file level restore. In this case, if we have a file server, for example, and Bob Nugget actually calls us up and says, hey, yeah, you know that file that's in that folder that I keep accidentally deleting? Well, I did it again. Can you restore that? Because I'm doing a file level restore, it is very easy for me to do that restore, because all I got to do is go to my NetBackup or my backup exec, and I look for the file and I click restore, and then poof, it's restored back to the virtual machine. This is, again, the traditional method of doing backups. Now, I can't do, however, full VM level restores here because I'm not backing up the VMDK file. So doing bare metal restores by doing this is just as easy, or really just as hard as it's always been throughout all the time up until the point virtualization arrived. It's very easy to do quiescing because all of the clients these days have quiescing technology built into them. You know, any kind of backup agent that you buy these days has got an agent for Exchange, an agent for SQL, an agent for domain controllers, etc. There's system state quiescing, those sorts of things. So it's very easy for us to quiesce the databases in order to properly back them up. But as you can see here, the load on our ESX server is very high. We've got a pretty high load on the ESX server by doing it in that way. And we can't do really LAN-free backups. All of that backups has to go over the LAN in order for us to be able to move that data into our tape. And again, this is VMware's words here, but it says here that the manageability of those servers is very poor. And if you think about it, and I think what they mean here by manageability is they're meaning that there's just so much data that you have to be able to manage and monitor and keep aware of and make sure that your tapes are all right. There's just so much more data that you have to deal with, and so that's why the manageability here is very poor. Now, we've been doing it this way for as long as throughout time, since the beginning of computers, this is the way backups have happened. It's these method 3 and 4 here that are the new things that we get when we move into virtualization. When we move into virtualization, we put that backup client in the service console, and then it does that quiescing of the virtual machines. Now, we no longer really get this concept of file level restore, right? We restore the VMDK file, not the individual files in the VMDK. And so that becomes very, very easy. It's more like if I lose the whole machine, it's easier, but if I lose a single file, it's much harder. The quiescing is also excellent, but in here we're not doing quiescing of the individual databases, we're doing quiescing of the OS as a whole. It's still got some pretty high load on the ESX server, but we can't do LAN-free backup, and it still says here that it's very, very poor. Now, they're going to try to drive us towards VMware Consolidated Backup, which is their features that comes with VMware Enterprise Edition. So be aware the reason why all these say very poor is that because the documentation is trying to drive you towards VMware Consolidated Backup. Now, we talked about this application and OS crash consistency that we had before, and it's important to talk about those as well, because these are now my words, whereas before was VMware's words. With Method 1 and Method 2, we do get that OS crash consistency, and we do get that application crash consistency. Now, that's a function up here of having this quiescing capability of the application. Now, we have the quiescing at the application because it comes as part of the agent of our standard backup agents. Method 3 and Method 4 still are able to do OS crash consistency, but they may not necessarily have that application crash consistency because, again, there's no agent that sits inside of our virtual machines to say, oh yeah, by the way, Exchange, why don't you shut down just long enough for us to do the backup and then you can come back. So those are Method 3 and Method 4. Now, there is another method out there, and that's Method 5. And Method 5 really is the idea of the backup server being VMware Consolidated Backup. And with VMware Consolidated Backup, we have a little bit of a change in how we deal with doing our backups. And it's kind of an attempt to do the best of all worlds. Let me go ahead and show you a picture of what VMware Consolidated Backup looks like. Now I'm actually going to paste in an image here, and this image comes directly from the VMware Consolidated Backup essentially the administrator's guide. This is the 301 administrator's guide for VMware Consolidated Backup. So this is, again, this is not my information, this is VMware's information. So I want to show you what VMware is trying to tell you about VMware Consolidated Backup. So you can see this picture here. It talks about the LAN, and we have this ESX server that's plugged into the LAN, and we have this backup proxy that's plugged into the LAN. And the reason why I'm showing you a picture is because setting up all of the, again, what VMware Consolidated Backup is it's a piece of code that ties into various different types of backup software. It doesn't really do the backup itself, but it ties into various types of backup software, as you can see here, to be able to do this sort of integration between image-based backups and file-based backups. What you have to do here is you have your ESX server, and you have a client that sits on this ESX server here, and you plug into the SAN, and you also plug this backup proxy, which is another Windows box, into the SAN, and you see down here you have your VMFS data store. You install this VMware Consolidated Backup tool set onto a Windows box, which may be your backup server. And what it does is it provides essentially a file share that allows you to not only back up the VMDK files, but also back up the individual files as well. And then also you can restore those individual files by mounting the VMDK file once you've done the restoration. So it's kind of a best of both worlds solution, because you get the ability to back up and quiesce these VMFS files, but you also get the ability to, with a couple of hoops that you have to jump through, you get the ability to restore individual files based off of a mapping in your file system. So you end up with, it's not really a drive letter, but it's a kind of you can think of it like a drive letter in your file system. So you open up the VMDK file and be able to restore files out of that VMDK file. So again, this is essentially VMware Consolidated Backup. And what you need to know specifically is that it integrates with your existing backup solution, and it provides you the ability to not only do image-based backups, but also individual file backups using this backup proxy as the location where those files can be restored from. It comes in as read-only. You can't write to the files, but it allows you to get those files off so you can get them back into the ESX server and back into the virtual machine appropriately in the way that you need to. Now, what's neat about VMware Consolidated Backup is that it comes for free with your Enterprise Edition version of VMware. But anything that comes for free, you always have to be hesitant about anything that comes for free. So there are additional tools, third-party tools. You saw me pop up here, method number 6 over here. There are some third-party tools that you can do that may be a different. They may have a different backup server that's either on network or off network, or it may be in the VM or not in the VM, or it may be clientless. There are a number of tools out there that can do some of this file level restore, that can do full VM restores, that can do quiescing as well, but that may have a little bit easier of a management interface. Probably one of the most difficult parts about VMware Consolidated Backup is its management interface is a little bit challenging. And so for a little bit of extra dollars out there, depending on the product that you're looking for, there may be additional products out there that may help you with that backup and restore capabilities. Some of those products out there, and I'm not going to name any names, but some of those products out there have the ability to do VM quiescing. Some of the products out there have the ability, or will soon, or may soon have the ability to do a quiescing of databases inside of the VM. So some of these other options are out there as well, and the moral of this story is do your homework. There are a lot of different ways out there, as we talked about, to do VMware backups, and depending on what it is you need to do may depend on what it is you end up needing to buy. And so as we said here in the beginning, that because you're virtualizing, you're adding a lot of different backup options, and you have to think really hard about what it is you want to back up. Now again, the rule of thumb, at least this is Greg's rule of thumb, is that if you have transactional databases, You need to have some sort of something inside the virtual machine that quiesces those databases. If you don't have transactional databases, then doing image level backups is going to be just fine. You'll be just fine. Or there's the possibility that if you don't care about data loss, now that seems blasphemous, but for some people, they really don't care about the data loss. If I lose if I lose, 15 minutes of exchange mail, I'm going to be okay. I can then just do that type 3 backup where I'm backing up the VMDK file under the understanding that in a disaster recovery circumstance, it may take me 4 or 5 hours to get the database back to consistency again. So again, there's a lot of thinking, a lot of engineering that you're going to have to do involved with backup and restore in order to get the stuff backed up that you want and also the stuff restored that you want. Now, we also want to take what we've talked about in terms of backup and restore and kind of bleed into this disaster recovery. Now, we could spend lots of nuggets. In fact, we could almost do a whole series on disaster recovery options with virtualization, but we want to just touch just a little bit on what options are available to you for disaster recovery inside of your virtualization environment once you set it up. So let's go ahead and create a new picture here and talk for just a little bit about some of the options that are available to us when we move into virtualization and how that can impact our DR plans. What I want to show you here are really two different kinds of mindsets associated with disaster recovery. And the two mindsets, we're going to talk about the really, really low cost mindset and the really, really high cost mindset. And there are various iterations between those two mindsets, but if you know what's at the very bottom end of the scale and you know what's at the very top end of the scale, you can probably interpolate and figure out what the different options are in the middle. I'm going to do two pictures here, the first of which is sort of our low cost. So, the single dollar figure instead of the 4x dollar figure. And in our low cost mindset, let's say we have our data store here. I'm really trying to make these data stores look better. And we have our ESX servers here. And we have some sort of tool that is backing up our VMDK files. And so we're doing this at least option 3 and option 4. And we may be also doing option 1 and option 2, and it's worth mentioning too that there's nothing that says that you can't do 1 and 3 or 2 and 4 or 1 and 4 or 2 and 3. You can do combinations of file level and image level based on what your needs are. So we've got this agent that's sitting in here that's doing some sort of backups for us, and the files are sitting out here. These VMDK files are sitting out here. Now obviously our virtual machines are sitting out here, but the files are sitting in our data store. If we do a VM level backup and we have our tape drive that's sitting out here, and this information that makes up this VMDK file makes its way onto tape, if I just don't care about any of my applications, I don't care about Exchange, I'm okay with losing a little bit of data, I don't care about my SQL, I'm okay with losing a little bit of data, it is very easy for me to just snap each one of my VMDK files, stick them onto tape, and then take the tape drives and put them somewhere in a fire safe in another site somewhere. That's really the lowest cost way of doing things, because if for some reason this whole thing goes boom, and I need to replace it, the process of actually rebuilding my entire environment is little more than going back, getting another tape drive, getting my tapes out of whatever lockbox they're stored in, and then finding some servers to put those VMs back on again. Now remember, it doesn't matter if that server is a Dell or an HP or an IBM or a white box or whatever. Once we add that virtualization shim layer in there, all of our hardware is exactly the same. So it doesn't matter where we're restoring it to, as long as it's got ESX installed on it. So this is kind of our low cost. Now it's low cost because it's kind of high work, right? If the disaster occurs, you got to go out, you got to go get the tape, you got to put it in a drive. It's going to take you a long time to actually restore those tapes or restore those files. Even though they're VMDK files, they're probably 20, 30, 40 gigs in size. You're going to have to restore those into another location, onto another SAN, and light them up, hit the green VCR button and light them up, make sure they're in the right order, domain controllers first, followed by, the things that need to have dependencies on each other. But you can line them up and then you're back in online again. Now this, it really has to do with your recovery point objective and your recovery time objective, which is, how much data can you care to lose and how long can you be down, right? If your service level agreement says that you can only be down in a disaster for an hour, then this low cost solution isn't going to work for you, because it might take, depending on the number of virtual machines, it might take 2 or 3 days to restore all your virtual machines. But if your service level agreement says, okay, if we have a disaster and a tornado hits our data center and you have 5 days to get the environment back up, well, then this low cost solution may be all right for you. You don't have to spend any extra money. Now, for a lot of people, these low-cost solutions are great. But there are certain circumstances when you go and you buy VMware Enterprise Edition, and when you've spent all that money, you want to have all the fun, fancy features associated with the Enterprise Edition. You don't want to be down for any reason. And so in those cases, you're going to go with the high-cost option. Now, it's a high-cost option because you have to buy the Enterprise Edition, first of all. And then you've also got to buy some other software as well that enable the moving, the replication of this data to go from one site to the other. Let's go ahead and put this. This is our high cost option here. Here's high cost, and this is our $4 sign here. If you go to those restaurant reviews, and it shows you $4, and those are the restaurants you never go to, or at least the restaurants I never go to. So here we have, and I'm going to draw this again. Here's our data store here, and then there are ESX boxes that you've seen so many times, and our little stripe there, and we're connecting into them. Now, with the high cost option, it's high cost because we are afforded low downtime. And when we're afforded low downtime, what we need to have is really a hot site, or at least a warm site. So this is our disaster recovery site. And inside of this site is another data store, with another stripe in there, right? And inside of this site may also be some ESX boxes that are just sitting there. They may be powered off, they may be powered on, but they're sitting there and waiting for the tornado to hit. The high cost occurs because some sort of software has to be implemented to take these little files that are here, and as each individual little file changes, there has to be some sort of network connectivity between one storage area network and the other storage area network to replicate the changes over to our disaster recovery site. Now stop and think about that for a second. Every time that a change happens to that VMDK file, it has to be replicated over from our production site over to our disaster recovery site. Now that's a lot of data potentially. Really, it depends. If it's a very, very high use, high transactional database, yeah, it can be a lot. It can be too much. You might need a very, very expensive leased line here in order to get that moved over. But if it's for the most of us, a low-end network connection, once we have the initial transfer moved over, the changes may not be that much if we don't have that many changes. So a low-end network connection may be what we can do. And you have to have some sort of software here that does the replication. Remember, we have OS crash consistency and application crash consistency. So for us to put that software on the SAN, remember some SANs have replication capability built into them. If that software is sitting on the SAN and the SAN's doing SAN to SAN replication, that's going to give us OS crash consistency if it's quiescing the VMDK file. If it's not, then we may not get that. If it doesn't have an agent inside of the machine, then our transactional databases may have some problems too. So you may have to have a combination of not only SAN to SAN replication, but also some sort of agent that replicates what's inside of the virtual machine across to the other side as well. You can see where this starts getting really, really high in cost. You also have to have the networking backbone functionality that knows that whenever this side goes down, that the other side will pick up with the same IP address scheme. Because you want those same IP addresses, because all you want to have happen is whenever this site goes down, you want to walk over to your other site or term server over to your other site or RDP or whatever and hit the green power button on each one of your virtual machines. If you've got a 1 hour SLA for being back up again, you're going to need to make sure that you don't have time to re-IP all your machines. So you can see here we've got dollars here because we've got to have the extra storage area network. We've got dollars here because we've got to have the extra ESX servers. We've got dollars here because we have to have the network connection to the replication. And then we also have to have dollars here for whatever software is doing the replication to move it across. That's why it's $4. So think about this. For a lot of people, this is way overkill. But for some people, maybe you're a bank, maybe you're a financial institution, maybe you're selling something on the web, you're an e-commerce sort of site, and you can actually measure downtime by the minute in terms of dollars, then these high cost capabilities are something that you may want to look into. Now, what's interesting about this is that none of this was really capable of being done until virtualization existed. These replication tools out here could replicate, but they wouldn't replicate very well, or they wouldn't do it with crash consistency, or those sorts of things, or you'd have to have, for every machine in the physical world, you'd have to have over on this side, you'd have to have another one on this side that's exactly the same. So you can see that even though it's high cost, it is still a lower cost than completely replicating your entire environment in a disaster recovery site that never gets used unless your first site goes kaboom. So think about that. That's really the moral of the story for this nugget, is that there's a lot of thought process that has to go into whenever you implement VMware, when you implement your backup, when you implement your restore, and whenever you start thinking about those disaster recovery options. A lot of times people, they do VMware because they're running out of power and space in their data center, or they think it's a cool technology, or they want to do compression, or for various reasons. And then once they get the virtual infrastructure installed, then they go, oh, wait a minute. There's all this disaster recovery stuff too that I can add. So it's a lot of times it's a follow-on project. So what have we learned in this nugget? We've learned about how virtualization adds those backup options, but it also adds the complexity. So it gives you the option to be a little bit of a backup architect, if you will. And we also talked about how virtualization adds some really cost-effective disaster recovery options. These DR options, they look expensive, but they're a lot less expensive than completely replicating your environment across from one place to another that never gets used until you get hit. I hope this has been informative for you, and I'd like to thank you for viewing.